Hi, my name is Christos Zoulas, and I've been with NetBSD forever. And for the past year, I've been trying to get NetBSD to work with reproducible builds. So this picture is very relevant to me because although this is a very old picture, my first contact with reproducibility is my homework when I was in elementary school. And although they had a much more modern version of this, that's how they gave us our homework. And, it looked almost the same, so it was kind of consistent. But why do we want to have reproducible builds? So first of all, would you buy a product that's different every time? Like, let's consider you buying a soft drink. Like, would you buy a product that tastes differently every time, or depending on if it was manufactured in the States or in Paris, or if it was manufactured today or tomorrow and tasted differently? Yes. Or, yes, you would. Well, I don't think that everybody else would. But anyway, or depending on which factory built it, or if it was raining, or if it was hot or cold while it was built. Well, I don't think so. And, in science, reproducibility is one of the major cornerstones. And, very lately we have seen even there, complaints from the scientific community that there is kind of lack of reproducibility. People are coming up with, very wild claims, and other laboratories around the world have trouble reproducing them. And this is because we don't really have a clear process to go from the ingredients or from the basic premise up to the result. And so there is a lot of gaps in the way that we're describing our processes, and these kind of gaps make reproducibility impossible. In software we're doing well with open source, but then we're also doing poorly because we don't have a real good engineering process when we build things. And yes, we can sign the result of a build, the package, the installed media, and we can sign the source that built the media. That provides, that we trust the person who built it, and we trust that nothing has been tampered with it in the process. But, can we verify that this person built this source and produced this binary artifact? And today, for most things, it's impossible because, even if we take the source and build it ourselves, it won't match. So reproducibility is all about the ability to make sure that the path from the source tree or the repository down to the distribution media, the CD-ROM, let's say, is producing exactly the same results. There are people who are saying this is a waste of time, and we shouldn't be doing that. We have better things to do. Instead of spending time twiddling bits and timestamps, we should really be fixing bugs. All of this 100% reproducibility is kind of useless. We should make sure that at least we have certain things that are reproducible. For example, the results of the compiler. If you build a particular binary with particular compile flags, it's the same all the time, but not go all the way from source to binary to CD-ROM. And that makes life really complicated for everybody because you end up with a CD-ROM that looks like an onion. You have to keep, picking up and picking up and picking up and taking things apart until you find out why the checksum of that CD-ROM doesn't match to the one you actually just built right now. And the implanted backdoor is real, but it's getting less important if you sign things. And bitwise reproducibility is attainable. Lots of open source products, if you look at reproduciblebuilds.org, have achieved that. So I was very lucky to start with NetBSD actually, because it made my life very, very simple. People have done most of the work already. NetBSD has a single source code repository. I don't have to go around the internet and fetch tarballs to build a distribution. There's an integrated tool chain. That means that already, because people have been thinking about this, everything that is supposed to be building binary artifacts that are participating in the end product has been toolified So that means that there's no external dependencies to the operating system, to use the operating system tools to build things that I need to be reproducible. And there's cross-build enable. So basically, what it means is I can build on a different operating system, and that's what Debian, the Debian folks do with reproduciblebuilds.org. They just download our source, they run build.sh, and that's all they have to do to get the full NetBSD build. And we can build on different CPU architectures trivially on cross builds. Because these days, nobody wants to build on the slowest CPU they have, they build on the fastest. So that means that for most architectures, this is a different architecture than the target architecture. So if you go to this website, you see basically you'll see exactly this. The red stuff is mine. So they build things twice. They add a few variations, which I'll get later. They're comparing them with a tool called Diffoscope, which is basically diff on steroids. So this tool is a great tool. It's responsible for actually peeling the onion. You give it a CD-ROM and it goes down and takes it apart until it finds the source of difference, and then it runs the appropriate tool. For example, if that's an ELF file, it runs, for example, readelf and compares the sections and then prints the hex differences. So, and all of that is on the website. So it's very nice because, every week I went there and I was disappointed by seeing my builds were still different. But on the other hand, they could just pinpoint all of the parts of the builds that were different. And that runs all automatically. And right now, since I think the beginning of the year, like in February, March, we are fully reproducible on both architectures, on SPARC 64 and x86 64 that gets built weekly on Debian. So Debian varies a few things. As you can see, some of the things are not being varied. So it varies path, language, environment, time zone, etc. And it also varies the UMask. It doesn't vary the CPU. It doesn't vary the file system. But these are the things that people are considering, as the sources of differences that prevent us from doing reproducible builds. Well, if you distill them down, there are really 10 categories here. So there are timestamps, as dates and times embedded in the source code. We build things depending on time zone, and we, embed timestamps that are time zone dependent. Parallelism is another issue on source order. If we try to build things with random data inside them. A really nasty one is path normalization. The tools that I mentioned, build parameters, environment variables, and finally, it would be nice to be able to build as anybody and be able to build a CD-ROM that is exactly the same. So, what timestamps do you use? So it has been decided that the best timestamp to use is the latest timestamp or the latest commit. And we call that MK repro timestamp for historical reasons. We might change that so it's exactly the same as Linux. All the file system objects get this timestamp. So to find it, when we start the build, we have to, get the timestamp of the latest commit. That's very easy with Git and Mercurial. Unfortunately, CVS, we use CVS, it's not. So, I don't want to get too much into that slide, but let's put it this way, that CVS takes a view of the repository as a directory by directory and file by file. There is no kind of global view. So there is also an issue with updates versus checkouts, because updates make the files have a current timestamp, and that's because it makes sense. Let's say that you're in a directory that you're building a program, let's call it foo.c, and you just build it. Now you CVS update, and there's a newer version of foo.c. You want the new foo.c you just download to have the latest timestamp, so it's newer than what it was just built, because it was just updated, and so that it gets rebuilt next time you run make. On the other hand, this is not the right timestamp, so I just added a flag called -t to check out consistent timestamp. So when you update your tree to make reproducible builds, you can do that. And finally, I wrote a tool called CVS Latest that scans the CVS repository, all the metadata files in the CVS entries, and finds the latest timestamp, and that is becoming your timestamp. Then you have to add timestamp support to everything that embeds timestamp in its output format. And the first three are obvious, backslash, makefs. The second one, less so, but it is because it uses dynamic UUID generation based on timestamps, so this has to be deterministic too. R in the new builds already has -D for deterministic builds, and that basically makes all the timestamps 0, and the UID and GID it embeds in the archive 0, which is very nice, and because it's not very useful, people don't use R as a file transfer to preserve timestamp format anymore, so the timestamps in there are less than useful. And finally, all of the documents that use the macro to print the date that the document was formatted need to be changed. And for that, expedient says, just take it away, so I just disable it for, conditionally the make file if it was doing reproducible builds. So for embedded dates and times, you have to remove these three macros from the sources, and that's what I did. Eventually you can put them back and have CPP obey the environment variable to put these variables, to set those variables based on the correct timestamp. And again, there are file system formats that want to obey local time, like ISO images, and for those, again, you have to make it consistent, so you just choose GMT in this case. So going to the next step, we have directory and sort order. So things that scan sets of files and from directories to build artifacts, they need to order those, and then, which was easy to do, you just sort them. But the most problematic one was basically install info. So when you do a parallel build and you use install info, every program that you build puts its information inside the global info file, and that means that this ends up being out of order. Since it's complicated to fix every version of the tools out there, I just decided to just write a simple text for processing tool to sort them after the build was done, each build was done. By far the most complicated and painful one is GCC. And GCC has many, many different nuanced issues here. The first one is basically the expansion of __ file. And for that, you can use -iremap, which is NetBSD extension. By the way, there are patches for these in the NetBSD bug website, but there's a controversy of how many or which one of these and how to do them exactly. So the first one is easy. It just remaps the path. The second one is a little bit more complicated. So there is a -fdebug prefix map inside GCC right now. The problem is that you can't really put the source path in there, and that's why this thing is quoted around it. It's because if you put the source path, what happens is that the expanded source path ends up in the DW80 producer and DW80 comp dir path. So here, oops, sorry. There. There. So you see, basically, if I was putting the full source path there, I wouldn't get this symbolic path. I would get the expanded path. So that would be different on every build depending on where I build. So the extension here to GCC was basically to go and expand the environment variable in the source if it finds a $, instead of having to put the expanded path there. And finally, the more complicated stuff was after this is applied. So basically now your tree is already normalized to user source. Depending if you're building on NetBSD with object directories or not, your build paths become different. So I added another option called debug regex map. I mean, I guess that GCC has people have trouble taking this one. They will never take that one. So I don't know what to do about that. But nevertheless, what that does is it uses kind of a regex capture syntax, like I said, to map things around so that things are being consistent if you're using object directories or not. The same thing trivially is added for lint, again, for lint libraries. And that does it with paths from GCC. Now, unfortunately, we have to deal with symbolic links. And, you know, it's fine to limit your build saying, okay, it has to be rooted at a particular directory and that has to be user source. I mean, that's a limitation. But we don't want that. We want people to build without root and to build with whatever directories they want to build, and those directories can contain symlinks anywhere. So the problem is that programs, when they start up, they can either believe what PWD is, verify it, or use getCWD to get the current working directory. So typically, what we wanted to do is we wanted to be consistent. In make, if you type cd other dir and make, depending on what shell you use, this can actually take the logical path and convert it to physical before it runs make. And that kind of screws up things for us. So the solution there is to basically make obey the working directory, and then instead of using the shell to change the directory and then invoking make to basically use make directly to tell it to change to the path. That feature already existed, so you can do that. And we did that because make is already a tool, but the shell is not. So basically we're using the operating system shell, so we can't depend on it. But we build our own make, so we can depend on it to do the right thing. So what is a tool now? So this is a list of all of machine-independent tools that participate in the build. So these are all the programs that produce some kind of output that needs to be consistent and needs to be guaranteed to be there. Some of them, they don't exist in certain tool chains. For example, if you build on Sigwin, you might not find some of them, might not be installed and you don't want the build to break. Or some of those might are particular to NetBSD, such as Jenison. Some of them are used for Kerberos, like compile-t. There's a lot of them out there, but this is the total set of machine-independent tools. Machine-independent means that no matter what the architecture is, I need those tools and they have to produce cross-architecture independent builds. Then we have the tools that are machine-dependent, which is basically your standard tool chain, assemblers, linkers, etc. You will notice that make is both machine-independent and machine-dependent. That's because make knows about your current architecture, and this make is the shell script wrapper that is architecture specific, where the other one is the architecture neutral. So the other thing that's very complicated, as you well know, is that every package has different build options. You can build with different backend libraries, with different defines, different features, this and that, and the NetBSD process avoids all of this by providing build defaults. So every program that's packaged on NetBSD has its own defaults. Unfortunately, we don't yet provide full isolation, so if you have an mk.conf that has different values and you don't specify that it shouldn't be used, that will override some of the parameters and may produce incompatible builds, but it's simple enough to fix. We just haven't done it yet. So this is a set of parameters, for example, that have values, not just booleans, and these are the tunables that we have in NetBSD. So you see, there are just too many of them. If you wanted to build, a build for every single combination of them, you would have, I don't know, what is it, like 12 times 7, 2 to the 12 times 7 kind of combination of builds, and that is unwieldy. I mean, some of them we should just get rid of. So as far as the last part, which is like the isolation of the build environment to provide a reproducible build, you can go for the extreme case where you totally control the environment, which means that I'm gonna only be able to build reproducibly if I have a VM. So I construct a VM, I know the exact VM parameters, and then I can only build in the VM, and this is the only way I can make reproducible builds. Well, that's the easy part, but it's also the least satisfactory one. But you have to go both ways. You have to both fix the source and fix the things that are easy to fix, and then the things that have value as opposed to depend on your environment to give you reproducible builds. So, for example, all of the things that we did to sanitize the source and sanitize the build system are great, But if you wanted to build as non-root user, it's harder. But fortunately, NetBSD has already done that. And so you can just pass a flag to the build to basically build unprivileged. And the way to do this is basically, we teach all of the programs again that produce artifacts that contain user information, like patch, make effects, and install, to be able to take a specification and produce them. And that specification is with a program called M3, which is very common, all the BSDs have it, and actually we recently synchronized it between FreeBSD and NetBSD, so it's almost identical. And make sure that the only thing that actually installs binary artifacts, those be directories or files, is installed. And then when you do that, you can only use install to install those files. And by specifying this flag, the install program, instead of setting the permissions on the destination files, it just appends them to the metalog. So when you actually build tar files or you make a file system, you can tell it to consult the permissions for those paths from the metalog and put them inside the binary artifacts using the correct user. So you can actually build without being root and end up with the same results. So to build NetBSD current and NetBSD 8, they're all already built with reproducible flags. You just need to say build with say -P, which means that if you go to the release engineering website and download the binary artifacts of a particular build at the source state for a particular architecture, you should be able to run the same build, build the same, that source you just downloaded, and your binaries that you build should be identical to the ones that you downloaded from the build server. So the reproducibility is not checked though, which means that we yet are not doing two different builds with variations like Debian does to make sure that we haven't violated reproducibility in our builds. We should upstream the GCC patches, and then, as I mentioned, we gutted a lot of time date reporting on boot logs, for example, the CPP micros on NROC for expediency to basically have reproducible builds. We could put those back to just be consistent. So you can see, as you can see here, this is from one of my machines called Broadway, and you can see that the shell has the right timestamp when you list it. If you stat PS, again, it has 1231.32. And if you run uname, you can see that, again, that was the timestamp that the kernel was built. It's pretty neat to see the whole file system have one timestamp. There are other bugs, and we need to add more sources of randomness during the build. One of the very important ones is that we have sometimes uninitialized memory, and setting it to different values between builds can actually reveal more sources and more bugs that we have to fix. ASLR is again a big help. Basically what that means is that if you're storing pointers that you have malloc in the build, these change, and instead of being always the same, so when you compare them, you can see that they're actually storing build pointers that would make no sense as opposed to zeros in your data structures. In particular, this one was storing stuff inside the superblock of FFS and makeFS. And then, there is other randomness that is in tools that we haven't fixed. I mean, basically, there is a bug in GCC on some of the RISC machines when you build with profile. It uses the function ID number to build labels, and that function ID number changes depending on the order of optimization of some function. So you have to turn the optimizer off to produce consistent results. Apparently there's some randomness in sorting the functions or processing the function, the processing order function. And finally, I would like to thank the NetBSD Foundation for having all of this stuff almost ready to go, and the Debian people for giving us both the infrastructure and being a very strong force for everyone to work towards getting most open source to be reproducible build and supporting great tools such as Diffoscope, and the individuals who actually worked on reproducible builds like Jörg and Thomas, and the people who worked on Luke and Todd who worked on build.sh. So thank you very much.
Are there any questions?
Hi there, thanks for the talk. I don't have a real question, but I just have something to say that you might also find interesting, and if you find a solution for it, then that would be awesome. So for Cloud API, I also do EuroBSD practicals, and I've noticed if I build on Debian, I get different binary packages compared to when I build on FreeBSD. And the reason for this is really nasty. So inside of Clang, there's actually some optimization that it optimizes out constant calls to liven. So for example, what you call the sign function with a certain constant, it fills in the resulting floating point value. But the value that it fills in into the assembly depends on the sort of the math library you have in the system. So Linux math library is slightly different compared to BSDs.
Yeah.
I mean, you just get like the last couple of floating point bits that they're different.
Yeah, that's a tough one to fix. I mean, these tool chain bugs actually, you know, they're hard to fix. I mean, there are different ways of fixing them. But
yeah. I also noticed the same thing with Clang, that depending on whether it uses libSD, C++, or C++, it uses a different hash map implementation internally, which causes, in the end, that certain instructions in the assembly are placed in different order.
yeah.
So.
Yeah, this is the whole frustrating process of, you know, getting to the last mile and saying, you know, that I finally produce two identical results. Some of them, you know, are really nasty to fix and they don't depend on you, and you have to have a lot of buy-in from upstream to tell them, look guys, you know, we want a reproducible build, so make it reproducible. Okay. Anybody else? Thank you very much.
But there's one more.
This one?
As a direct reply to that, there are some efforts in LLVM land on finding bugs related to iteration order of data structures. So they're currently adding new options to, for example, force reverse iteration of certain data structures, or having explicit different iteration orders for the data structures and that flag, and to flush out these kinds of bugs. The second one about the constant folding, just don't do that. Don't depend on constant folding of first dimensional function. It's supposed to be fine for all the functions where the standard actually says the result must be precise.
Thank you.
All right, thank you very much.
Oh, another question.
It's a comment, not a question, but over from the Debian Reproducible Builds project says hi, and would like you to come to the Reproducible Builds Summit coming up in Berlin.
Okay, thank you very much.
Early November.